Hi everybody. So this morning what we're going to do is we're going to make a foldable to help us with our studies of meiosis. So as always, the first thing we have to do is gather our materials. So you're going to need one sheet of paper, and you're going to need two different colored pencils. I'm going to use orange and I'm going to use green. So whatever you want to use, it doesn't matter what the two colored pencils are. So the first thing that we're going to do is we're going to take this piece of paper and we are going to put a crease in it so that actually fold it hot dog style and put a crease in it so that it looks like this. Okay, and then make sure that crease is down there pretty tight. Use your nail to push it down, because we're going to open it up again and we're going to tear it along that crease. That's the key to tearing correctly, is having a nice pressed down crease. Okay, so we've torn it, and so now we have two pieces of paper that kind of look like this. And what we're going to do is we are going to tape the two pieces end to end together. Now, if you have available to you a nice long sheet of paper, you could just use one long sheet of paper and you wouldn't have to tape. But I don't have a long piece of paper with me. I just have a regular piece of printer paper. And so if that's the case, we're going to tape the two ends together side by side. So here's my tape, as you can see, kind of see, I guess. And so then what we're going to do is we're going to fold it in half, and then we're going to fold it in half again, and then we're going to fold it in half again. So if you've been counting, that means we should have 8 sections when we open it up. Let's see what we have here. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's good. So now what we're going to do is we're going to take one end and we're going to fold it accordion style. So I'm going to leave this regular crease in here that folds it like this, but this next one I'm going to fold back like this. Go against the crease, and then I'm going to go against the next crease again, fold it back. And I'm going to keep the next natural crease, fold it back, so it's kind of like an accordion, okay, when you're all done. So if you look here, so it will open up like this, right? So it opens up like this. And this crease is up, this is down. This is a hill, valley, hill, valley, hill, valley, hill, and valley. So if you've got nothing but hills and valleys, then you've done it correctly. Okay, so what we're going to do is we're going to start with the side. Turn your accordion, right? This will be a storybook, actually, is what it's going to end up being. Turn your accordion so that it opens like this, okay? So let me put this over here where you can see it. So that's how we're going to do it. And on the front here, you can entitle this anything you want. I'm just going to call it The Story of Meiosis. And I'll probably get some clip art off the internet or something like that and paste it down here. Or you can come back and do it on your own. So then we're going to open this up like this, okay? And the first thing we're going to draw is a cell. So draw yourself a big cell. And then in the cell, let's draw a nucleus. And I want you to see here, this nucleus that we've drawn is actually a whole lot bigger proportionately than what it is in a real cell. In a real cell, the nucleus is very, very teeny. But we're going to make it big here because we have to put some things inside it. And if we don't make it big enough, we're not going to be able to see the things that are inside it. So inside this nucleus, let's draw 2 chromosomes. And we're going to make one of them bigger than the other. So there's my big orange chromosome, and then I'm going to draw a much smaller green one. Okay? And let's not forget the chromatids, which I'm just going to use, or centromeres. I'm just going to use a regular pencil for that. And so let's label it just one time so we know what we're doing and what things are. So these right here, as you know, are the chromatids. There's one and there's another. One came from one parent, one came from the other. And this little thing in the center here, we're going to label this as the centromere. And we don't have to write this again because you made another foldable that described the chromatids in the centromere. And then we've got the nucleus there, and then let's call this page 1, okay? So, there's what happens. There's where we're going to start, with a regular cell that has 2 chromosomes in it. So on page 2, let's start telling the story before meiosis begins. Okay, and I'm not going to draw the nucleus, but before, let's just draw a big nucleus. I'm not going to draw the whole cell, is what I meant to say. What happens, as we can see from our picture here, is that the chromosomes duplicate. Okay. Every chromosome in the parent cell is copied. Okay, every parent is copied. Then let's go to page 3. On page 3, we'll draw a big cell again. And then inside the cell, we're going to draw something called spindle fibers. And what happens is that chromosomes, chromosome pairs, let's put down, chromosome pairs they line up in the center of the cell. Give you a chance there to get yourself caught up. Just a second's worth. Chromosome pairs are lining up center of the cell. It's kind of the center. It's close. Okay, page 3. And let's go ahead and label this one time spindle fibers. You're going to need that term in the future, so when we study cells, you might as well just learn it now. And then the cell starts to change shape. It turns into a peanut shape. And so what's happening, as you can see, is the cell starts to pinch in. Okay, we still have spindle fibers. So the chromosome pairs separate and they move to opposite ends. So let's put one of them here. And put one of them down here. Doesn't matter where you put them. The only thing is that try to get a centromere on one of the spindle fibers, because it's the centromere that moves along the spindle fiber that takes it to opposite ends of the cell. So I'm going to make sure we've got our centromere in here. Okay, and this is page 4. Page 5. Then what happens is 2 cells actually form. And I'm going to go ahead and put the nucleus back in here. Remember, this nucleus is way too big for the cell, but that's okay. And we're going to put centromere gets put in here. So 2 cells form. Each cell has half the number of chromosomes. From the original parent cell, and that would be from page 2. So if you look on page 2, each cell now has half the number of what we had on page 2. So let's take a quick look on page 2. In page 2 we had 1, 2, 3, 4 chromosomes. Now each cell has 1, 2 chromosomes, so half the number. Then on page 6, chromosomes move to the center in each cell. Put some spindle fibers in here. And it doesn't matter how, you can put the spindle fibers going the other way if you want. It doesn't really matter too much. And so, get this baby in the center again. And the centromere is on a spindle fiber. So it goes from here to here. Okay. Then on page 7, what happens is, okay, so I'm going to draw the peanuts again. So now it's the same story again. So what it does is it ends up repeating itself. The centromere split. The chromatids separate. And they actually become chromosomes at this point. And they move to opposite ends. So let's get some spindle fibers in again. And let's show these little babies going to opposite ends. Okay. We got our centromeres in there. And then what we end up with at the end of meiosis is that, as you can see also here on page 7, you can see these cells are starting to pinch in again, taking on that peanut shape. And so they completely pinch in, and we actually end up with 4 cells. 2 from this guy and 2 from this one. And then I'm going to go ahead and put the nucleus back in. Remember, this nucleus is way too big for this cell. And the centromeres on the little one too. So we actually end up with 4 sex cells getting produced with half the number of chromosomes as the parent cell. And this time we're talking about the parent cell on page 6. So if you look here, we have 1, 2 chromosomes, and here we have 1, 2, 3, 4 that we started off with. These, remember, they're chromatids here, so we have 1, 2, 3, 4 chromatids in the cell, and now we only have 1, 2 chromatids, but they're actually called chromosomes at this point, but that's where they came from. So, and then this is page 8. Okay, so now what we're going to do is we're going to take the back of page 8 and put glue on it, and so that will get glued into your foldable, and your teacher will tell you what page to put that in. So study this. It's a nice little study guide. It's made in booklet form because it is telling us the story of meiosis. So this is how we start with a body cell, and some of the body cells that are in our ovaries and our testicles actually turn into sex cells, into sperm and egg, and this is how that happens. Okay? So, and remember that the sex cells have to have half the number as what we started with, because if this is a sperm and this were an egg, then they would come together and double the amount. Remember, when Sutton did his work, he found out that the sperm and egg of grasshoppers had 12 chromosomes, but during fertilization, 12 plus 12 is 24, and all the body cells of the grasshopper had 24. That's the reason why our sex cells have to have half the number, because during fertilization it's going to get doubled. So, take care. We'll talk to you later. Bye.